So hi guys, so finally thought to have some sort of an some sort of a guiding session to give you some sort of help on how to face the dynamics of mechanical system final paper. Guys, during my college studies, right, during my university time, dynamics of mechanical system is a subject that I really loved because that's a very interesting subject. It's a very great subject. So, but the problem is many of the students, rather than studying the subject, they are trying to memorize the questions. Once they do some sort of a question, they are trying to memorize. So don't do that. If you really want to pass the exam, I think as I can remember, I nearly did 13 or 11 papers, little bit hard. You have to practice. Okay, so I'll give you a quick guidance. So first of all, when you get the paper, first of all just take some time and read the paper. Okay, and select what is your combination and like how you're going to answer. So mostly it contains vibrations and control separately. So basically in the vibration part, these are the questions that I answered the the rigid beam question, where you have some beams, then those beams are rotating, or that beams are just turning and one beam is attached to another beam. I think I have one sample problem. Can you see this? Is it clear? No, it's not clear. Okay. uh you know uh, shall we try this? No, I can't show like that. Okay, so the rigid beams, because there are a lot of examples in the course material about the rigid beams, so study that rigid beams. And then the transmittability, the mitigation of the vibration by using damper system, transmittability ratio, right? So they can it's how to say that, there are a lot of examples of using the transmittability ratio, so you can practice that because I really loved that part. And then the rigid beams, and then uh, and rotors, right? So vibrations of the rotors, maybe gearbox. There are a lot of examples in the course material because the course material is it's really great, right? So then right, okay, after finishing this video, then I will go to another mode. And then for the control part, root lookers is a very good part, right? But you have to practice because there are certain types of root lookers where you have real poles and no zeros, real poles and real zeros, imaginary poles, imaginary zeros, right? It's a complicated thing. I don't think after doing one problem you know everything. You can practice root lookers, practice all the types of problems. And body plot is also very easy, right? If you have practiced body plot, easy. During my time, I didn't try Nyquist plot. I didn't like it. Most of the time I tried root lookers and body plot. Very good questions. And design part, because there is another question based upon design during our time, so very good part. And another question will be there based upon they will give you a transfer function, and they will ask some certain facts: peak time, delay time, rise time, transfer function. I don't know. So you practice those. Okay guys, then I wish you all the very best for the dynamics of mechanics system final exam. So if you have any sort of a doubt, you can contact. Hi guys, so the final examination is closer, so then I thought to discuss the part B of that. I think this is 2016 paper, the part with the control part. Okay, so let's quickly go. Distinguish between part A, distinguish between open loop control system and closed loop control system. Okay, so let's see what's the answer. So, okay, open loop control systems. The control action is totally independent of the output of the system. Okay. Then practical examples: automatic tea maker, bread toaster, electronic hand driver, light switch, timer based clothes driver, like that. Okay, so open loop type. So then what are advantages of open loop type? Simple in construction and design, economical, easy to maintain, and generally stable. Now reason why the open loop type systems are bit easy, then very easily I can say, is there a transfer function I can show you? Now see guys, in see, now this is kind of an example for a closed loop transfer function, or this is something like a closed loop system. Okay, so in this system you can very easily see if the system is closed loop type, there is an additional loop coming. So additional loop coming means additional equipment coming, some sort of a how to say, an additional part is coming. So additional part coming means definitely it must be either expensive or it must be either like not simple. But open loop type, there is no feedback, that means it is simple. Okay, so disadvantages: inaccurate, unreliable, change in output cannot be corrected automatically, because now in open loop type system, you know, the output, like you can't change the desired output, you can't correct for errors. That is the fact. I hope it is clear, right? Because I'm quickly covering. Okay, so disadvantages, yeah, so those are the disadvantages. So now we are moving on to closed loop control system. Output has an effect on the input quantity. Input quantity will adjust itself based on, because now in closed loop type control system, the output is adjusted based on the previous output, like it is like regulating type, right? So it is correcting the error. So that is the advantage of closed loop type control systems. So there are a lot of advantages. The system is less affected by the noise, and highly accurate, as any error arising is corrected due to the presence of the because of the feedback signal, because of the feedback path. Even if there is some sort of an error that is arise, so that error will be corrected. Okay, so I hope it's clear. What are the examples? Examples. What are the examples? Cooling system in car, water level controller, and air conditioner. So those are the examples of closed loop type system. Then disadvantages, uh, what happened to the, okay, disadvantages: complicated to design, more maintenance, and bit costlier, not bit, like highly costlier. So then I have gone to the comparison chart: open loop type, closed loop type. So now you can see open loop type, feedback element is not there, feedback element is there, no error detector. In closed loop type there is an error detector. And open loop type stable. Mostly closed loop type, like it can become unstable. And open loop type economical, this is costly. Small bandwidth, large bandwidth, just for your knowledge. Okay, less maintenance in closed loop type system, because there is an additional loop coming, so maybe more maintenance. Unreliable. And closed loop type, that's reliable. Then what are the other stuff? Okay, so that's it. So now what's the next thing? uh, Define 5 transient response specifications and sketch it on typical transient response curve. Yeah, very important. These are the basics, right? So that's the problem, because you guys don't study basics. So transient response specifications. Transient response is a part of the total response which approaches zero as time approaches infinity. Okay, so that's the notation. Right, so basically, as you can see, there are certain response specifications. If we say rise time, overshoot, settling time, delay time, peak time, steady state error, so like that, just for your knowledge. Okay, so now this is the curve, as you can see, right? See, all are there in the course material, right? So study this stuff, will be maybe very important. So then we are moving on to the rise time. So let's quickly see what is rise time. Time required for the response to rise from 10% to 90%. Keep in mind that is the time required for a certain system like this to rise from 10% to 90%, or you can say 5% to 95%, or 0% to 100% of its final value. For underdamped, what is this? Underdamped. For underdamped second order systems, 0% to 100%. There are certain systems, no? So rise time is normally used for overdamped 10% to 90%. Rise time commonly used, what is that? Okay, just study this node. Okay, right? Because now basically rise time means time required in that particular response system to rise from, usually from 10% to 90%. That is the usual scenario. Okay, so I have written a big note over there. Then go for peak time. What is peak time? Peak time means time required for the response to reach first peak of the overshoot. Okay, uh, uh, in that there's a response curve, no? So the time required to reach the first maximum point. See, time required for the response to reach the first peak of the overshoot. Okay, so that's it. And I think in this part we are discussing all the definitions. And then what is delay time? The notation is I think it is TD. Time required for the response to reach 50% of the final value. The very first time, like it's like this: time required for the response to reach 50% of the final value for the very first time, right? So final value is the steady state, final value is the steady state value, and here I'm like, based on this certain reference, it is 1, right? Mm, then maximum overshoot, or you can say MP, maximum peak value of the response curve measured from one steady state value. Then maximum percentage overshoot equals maximum minus C steady state divided by C steady state into 100%. If there is no steady state error, that means CSS equals 1 and steady state final equal to input. If no steady state error, not, just go through it. Then settling time, the time required for the response curve to decrease and stay within a range about the final value of size specified by absolute percentage of the final value, usually 2% of like time taken for it to see time taken for it to settle at a range with it, which is nearly 2% or 5% of the final value. Okay, so that is what I call the settling time. See, some important curves are there, as you can see. Yeah, so that's the settling time. So this is the curve, and also based upon the all specifications, and there is a certain graph that describes the each specification. Like that is, like in the question, if they're asking what is rise time, what is peak time, delay time, just write the little explanation and sketch it so that it can express that idea. Now see, for an example like this, see, this is, I mean, like in this graph, I think this must be clear. Zoom out. In this graph you can see I have represented TR, but TR is the rise time. Okay, see this gap. So what is rise time? Actually, rise time, as you know, because I previously discussed that, see, time required for the response to rise from 10% to 90%. See, so now that's the definition. Okay, so now you can see time taken for it to rise from 10% to 90%. See, now it has reached like nearly 90%. It has reached 10% to 90%. I think that's the definition. Am I correct? Yeah, see, 10% to 90%. See, so you have to just, you clearly have to show that, right? Time taken for it to reach 10% to 90%, you have to show that. So use the appropriate graph or the appropriate response curve for that. Okay, and what for this curve? This is a peak time, time taken for it to reach to the peak, right? This is a peak time. There's steady state value, then maximum motion, like that. Guys, strictly study those curves. Okay, and what is this? The settling time. I told you what is settling time, right? Time taken for it to get settled based upon a certain region or based upon a certain percentage, right? So that's it. And now let's move on to the next part. What is the next part? What's the question? My god, already 10 minutes. C part. What are PID controllers and explain the main control objectives of PID controllers. Four control actions: on, off, two position, and then proportional, integral, and derivatives. That is how PID comes. Then proportional plus integral plus derivative. See this proportional, integral, like all three combination. Okay, so see guys, carefully remember these formulas, that integral formulas. Okay, and proportional control action. This describes the proportional control action. If you have studied the notes, you can get a very clear idea. Then after proportional, then integral control action. I'm not going to teach you anything over here, right? Just showing you the answers. You can just like do or manage something, right? If I show you the answers, you can manage something, right? That's it. And important formulas like these are terms, integral control action and proportional control action. And then the derivative control action, to have actuating signal proportional to time derivative of the error signal, right? So the answers you can just check it, right? This is how you show derivative controller, this is how you show integral, this is how you show proportional. And then main objectives of PID: regulation of speed, temperature, flow pressure, to control measurable variables, flow rate, chemical composition, feedback to match a set point. Benefit of PID loop is that designer can set it and forget it. What is this? Set it and forget it. Yeah. While maintaining a well-regulated system. And now the D part. What is D part? I think it must be a calculation-based part. Open loop D. Open loop transfer function of a unity feedback control system is given by a GS equals okay blah blah blah. Calculate the damping ratio and maximum overshoot. Oh, that's the first part. The open loop transfer function, okay, right? Just see the answer. This is the forward function having a unity feedback now, so feedback value is 1. So you know how to write this formula, right? So these are nothing, right? Now see, this RS signal is there, output coming, so here arithmetic process is there, so you have to get the difference, then multiply that difference from this, that will be ultimately equal to this. Easy, right? It's not hard. Then you can see the answers, right? You have to go and simplify the characteristic equation, then match that with the standard. What is that standard equation? S square plus 2 beta omega n s plus omega n square. So match this with the equation that comes from that chart, or that comes from that signal flow. Okay, you have to match the variables. If you match the variables, then you can find. Okay, then you can find whatever they ask, you can find. If they ask maximum overshoot, there is a formula for overshoot, right? See, there is a formula for overshoot. Then you can find peak time, whatever. Peak time, damp frequency. If you know the formulas, you can find. These are the answers, right? So later you go through them. Okay, I think this C, I think that stands for the response. Okay, study those, the formula for overshoot. Okay, those are the answers. You just match or check. Okay, so because in that part they are asking some certain questions, right? See, calculate damping ratio and maximum overshoot. I think that's what they ask. See, I think I have already calculated those. Okay, I have calculated those stuff, you can see. Okay, what is the next part? What do they ask? Guys, I'm sorry, because like here I'm not teaching you anything, okay, just showing you my answers, right? So that you can do something, because if I start teaching you this, it will take lot of time, because just now I'm sharing my answers. I'm also busy at this time, so this at least you can see the answers. What is the next part? If the damping ratio is to be made 0.75 using a tachometer. See guys, now careful. What is this tachometer feedback part? So that means you have to add a tachometer feedback. That's it, right? Then do the same calculations. See, so this is the scenario, right? So now you add in a tachometer feedback. That's it. No problem, right? So this is how it comes. The tachometer feedbacks. Then what happens? How to deal with this? First, this RS signal is there, then output signal is coming CS, so then there is an arithmetic signal that comes, RS minus CS. Then what? Then again this signal now see, I will tell again. See, this is RS, this signal CS comes, so this signal minus this signal, you will get this one. So that signal is flowing up to here, and then from that signal you have to reduce, which comes like this. So this is multiplied by this signal this CS over here, you can see it coming like this. See, dot 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 dot, it comes like this. Then from here again it is subjected to an arithmetic operation. From here it is that, so it is multiplied by this member, then ultimately will equal to CS. So simplification, then get the standard equation, then match and find the necessary values, overshoot or whatever. What is the formula for overshoot? E to the power minus 5 beta divided by 1 minus beta squared. Okay, remember the formulas. Okay, so that's it, right? And whatever the constant they are asking, just carefully match the values and then find. Understand, you have to remember the basic formulas. I think that's it. Yeah, I quickly covered that, so it's not hard. I'm just sharing my answers. If you have any sort of a doubt, you can just text me, okay? Because at this moment you should work these examples. So guys, please study hard, okay? This is a good paper actually, 2016 paper. That's a great, right? So this part I already discussed, the vibration part, vibration theory part, okay? Because you people are studying big things, not the theory. So the next part, what I did was, like, that's a today's part, the control theories. Then this the coordinate coupling, study those, okay? The gear system, like the torsional systems, right? Usually when I was doing the paper, like, I didn't try this part, you know, the design part. I don't like it, right? I do mostly like this part. I think root Lucas, I already did a kind of a video for root Lucas, right? It's up to you to practice the past papers, right? It's up to you. Okay guys, okay. There can be some problems, you know, they will give you some block diagram, they can ask some like damn natural frequency, those stuff, right? And also like there may be question based upon rigid beams. Now see, the beams are, now there are some rotating beams about one certain axis, so those beams are connected to another beam like this, so then they can ask you to prove some sort of a equation, some sort of a like a governing equation, so like this. Also maybe about the vibration measuring equipments, and you know the isolation methods, can study those, okay? So guys, first of all, carefully read the question paper and attempt only the questions that you have practiced, okay? So if you have never ever practiced some sort of a question, and if you are thinking for the very first time if you are going to answer that question in the final exam paper, guys, it's a joke, okay? Maybe you have practiced some certain questions, because I told you the number one thing, just prepare your writing pattern. I am going to answer this one, maybe for an example I am going to answer transmittability problem, then the vibrations of rigid rods, then torsional vibrations, then like transmittability ratio, then from the control part root Lucas body plot, then transient specifications or the control design part, whatever, just get prepared with your pattern, okay? And like for one particular question, and this is the most critical case, Say for an example, in the final exam you are spending 40-45 minutes on one particular question, and after solving that question for 45 minutes only you understand, oh my god, that is hell wrong, right? So don't spend more than 30 minutes on any question, understand, because if you are fluent enough you should be able to complete it within 30 minutes. If you are going too much on one question, then you will lose your time to focus on another question, and in case the question that you are writing or the question that you are trying is wrong, it will definitely put your mentality down, understand? So don't spend too much of time on one question, maximum 30 minutes, okay? So then attempt only the questions that you have practiced. Don't attempt the questions that you have not practiced. Okay, it be a joke. And don't have too much of hopes. Don't have that shit hope of I am going to score 195. Then in case if you could not answer one sort of a little part, then entire your mentality, entire your like that moral motivation becomes zero. So don't have big hopes, right? If you just want to pass the paper, then that's enough, right? Just pass it. That's enough. Okay. So that's it. I'm not going to say you answer this question, but okay, I will tell you. But like most of the time I answered the rigid beam part, transferability ratio, the transferability problem, then root Lucas, border plot. Those are my favorites. So like that, you prepare your own pattern, practice those own pattern type questions based upon past question papers, your assignments, course material. There are a lot of good examples. Practice those and attempt only the questions that you have practiced. Got it? So that's it. So any doubt is there, you can just text me. Okay, you can do. All the best.